Good morning, children. So today's class, we are going to start with a new topic, binomial distribution. Write the heading, binomial distribution. Okay, the name itself we can understand. Binomial. What is meant by binomial? Bi means two, isn't it? So here in this distribution, we will consider only, okay, in this distribution, we consider only two outcomes, either success or failure. Okay. In the previous case, that is in the earlier questions, which one we have discussed there, we had so many outcomes. When we toss a coin, we may get 1, 2, okay, and X is a random variable which can take all possible outcomes. But here, we consider only two outcomes, either success or failure. Either success or failure. Okay, so look at here. Suppose we toss a coin. Okay, listen, children. It's a simple one, only easy one. Okay, suppose we toss a coin. Okay, so when we toss a coin, we denote the probability of getting a head as success. Probability of getting a head is success. And probability of getting a tail, that one will be a failure. Okay, so when we toss a coin, suppose we take probability of getting a head as success, then probability of getting a tail will be failure. Now tell me, what is the probability of getting the success? What is the probability of success when we toss one coin? What is the probability of success?
1 by 2.
1 by 2, isn't it? And what about probability of failure? 1 by 2, isn't it? Here, the probability of success, we always denote it as P. Okay, look, okay, go through the notations. Look at children. Probability of getting a head, we take it as success. And the probability of success, we denote it with the alphabet, small letter P. P denotes probability of success. And Q denotes the probability of failure. Now add and see. What is P plus Q? What about P plus Q? P plus Q is, when you add these two, it is 1. So probability of success plus probability of failure is 1. P plus Q will be always 1. Okay. So in binomial, listen children, you can write afterwards, first listen. Just listen. So in binomial, okay, it depends on two variables. P is the probability of success. P denotes the probability of success. And N denotes the number of trials. N denotes number of trials. That means in binomial experiment, that number of trials must be finite. The number of trials must be finite. If you repeat an experiment infinite times, okay, then it will not be coming under the distribution, binomial distribution. Is it clear? You will be given with the situation and you will be asked to identify what type of distribution. So how will you identify a binomial distribution? Number of trials must be finite and there are only two outcomes, success and failure. Success and failure. And P plus Q must be always 1. If these conditions satisfy, the given distribution will be a binomial distribution. Okay. We are going to learn two more distribution. Okay. You should identify. So in the exam, they will not find the binomial distribution and all. They will simply give the distribution. You have to identify. Reading the questions, you have to identify. Okay. Binomial, we can identify it easily because the number of trials will be finite and it will be, okay, it will be countable 10 times, 5 times, like that, very small number of times. And P plus Q, probability of success plus probability of failure will be 1. So binomial distribution is always indicated in the form B of N comma P. It will be denoted as B of N comma P. Okay, what is N? N is the number of trials. P is the probability of success. P is the probability of success. Okay. So now take your textbook. If you open your textbook, page number 360, take page number 360. Underline all these. Okay, these are all important 1-mark questions. Page number 360. A random experiment with exactly 2 possible results. A random experiment with exactly 2 possible results is called a binomial or Bernoulli's trial. It is otherwise called Bernoulli's. A random experiment with exactly 2 possible results is called a binomial. It is otherwise called Bernoulli's trial. The 2 results are called success and failure in probability theory. Okay, only 2 outcomes. One is success, the other one is failure. Now look at the next paragraph. A binomial experiment is an experiment that can be regarded as a sequence of n trials. Okay, it has n trials, finite trials, where, look at the conditions, underline all these conditions, where n is finite. An experiment will become a Bernoulli's trial or binomial trial only if first case n is finite. Second one, each trial has exactly 2 outcomes, success and failure. Next one, the result of a trial is independent of the result of the other trial. Underline the word independent. The result of any trial is independent of the result of all other trials. What does it mean? What does it mean, children? Okay, imagine, okay, earlier we have discussed about the same thing, independent and dependent, isn't it? Can you give the example? When will you say the outcomes are dependent and when will you say the outcomes are independent? That one we discussed in the previous distribution also. Yes. Replacement, without replacement. We discussed. Yes. Yes. Can you give us an example or can you give a situation? Okay, listen. Yes, Aishwarya.
For example, in a bag of balls filled with balls, red balls and blue balls. So the first trial, when we get a probability of a red ball. So it can be replaced or not replaced. So the probability depends on it.
Yes. Okay. For example, look at this example, children. Suppose we have 3 red and 4 blue balls. Okay. 3 red and 4 blue balls. Suppose we have 3 red and 4 blue balls. Okay, suppose the success is denoted by selection of a red ball. Success denotes the selection of red ball. So what is the probability of selecting a red ball? What is the probability of selecting a red ball? Initially, when I take the ball first time, when I draw it first time. What is the probability, Anila?
3 by 7.
Yes, it is 3 by 7. Now, suppose I am not replacing it. I am not replacing it. Look at the ball are red and we remove it, we keep it separate. Now, in the second step, what is the probability of selecting the second red ball? What happens? Karthik, what is the probability of selecting the red ball?
2 by 6.
2 by 6. Now look at here. It is changing, isn't it? Although we consider probability of success as red, every time the probability is changing. Why the probability is changing here? Why it is changing? Because we are not replacing, isn't it? We are not replacing. As we are not replacing, every time the number of balls is changing. As the number of balls change, probability also changes. Is it clear? So this case, we can't take it in binomial distribution. This is not an example of binomial. Why? We are not replacing. As we are not replacing, probability of success will go on change. In binomial distribution, the probability of success must be fixed. That means all the events are independent events. Here it is depending. Here it is depending. The second event depends on the first event. Is it clear? The second event, the occurrence of the probability of selecting the second red ball depends on the probability of the first ball. Is or no? Suppose I am not selecting the first red ball. Then I will be selecting a blue ball, isn't it? In that case, you will be getting 4 by 7. Now, what is the probability of selecting the second ball? Second red ball. Suppose the second one is red ball, means in that case you will get 3 by 6. So, probability of the second event depends on the probability of the previous event. Then we call that events as dependent events. So, binomial, we can define it for only independent events. Underline that word in the definition. The events must be independent. Next one, the probability of success must be fixed. Okay, it will not change. Okay, write down these points in your notebook. Okay, write down these points. So, binomial experiment or trial. Okay, binomial experiment or trial, binomial distribution. Okay, all these things, the method. Okay, all these terms will be used. Trials or experiments, binomial or Bernoulli's. In all these cases, we assume this point. Okay, if these conditions satisfy, then the given experiment will be a binomial experiment or a binomial trial. First case, n is finite. Second one, only 2 outcomes, 2 possible outcomes. 2 possible outcomes. Third one, the events must be independent. Okay, the events are independent. The fourth one, probability of success must be a constant one, isn't it? It does not change, it's fixed one. It will not change from one trial to another trial. It must be same. Probability of success is fixed. If all these conditions happen, then we say it is a binomial experiment. And the binomial distribution is given by, write down the def, okay, write down, the binomial distribution is given by, binomial distribution is given by P of x is equal to small or P of x is equal to R, it is NCR P raised to R, Q raised to N minus R. P of x is equal to R, NCR P raised to R, Q raised to N minus R, where R takes values 0, 1, 2, 3, etc. up to N. R takes values 0, 1, 2, 3, etc. up to N. And N is the number of trials, P is the probability of success, and Q is the probability of failure. P is the probability of success, Q is the probability of failure, and N is the number of trials. And write the next formula. Mean is given by, mean of a binomial distribution is given by, mean of a binomial distribution is given by, is it over? Mean, we denote this as mu, which is equal to E of x, which is equivalent to NP. Mean is equal to, mu is equal to E of x is equal to NP. Variance is equal to, variance how we denote? Sigma square is equal to NPQ. Variance is equal to sigma square is equal to NPQ. And standard deviation. And standard deviation is equal to square root of variance, which is denoted as sigma, which is same as root of NPQ. Okay, if we learn all these formulas, the probability binomial is over. We have to do problems by applying all these formula. Binomial distribution is given by NCR P raised to R Q raised to N minus R, where P is the probability of success and Q is the probability of failure. N is the number of trials. N is the number of trials. Then what about R? What about R? Suppose we try, okay, suppose we try the experiment 5 times. I want minimum 3 success. Okay, we can try the experiment 5 times. Minimum success needed is 3. Okay, so R denotes the number of success. Okay, N is number of trials and R denotes the success. How many times we need the success? Sometimes we need 1 time or 2 times, etc. up to N. So R takes the values from 0, 1, 2, etc. up to N. R takes the value 0, 1, 2, 3, etc. up to N. So out of N trials, R success, probability of getting R success. Okay, now take the textbook, children. Again, look at the experiments given there. There are some experiments given there. Okay, in page number 360, last paragraph. Okay, one of you read that one. Anila Mohanan, read the last paragraph. Thus, the following are binomial experiments. Few experiments are given. Go through it.
Toss a fair coin 20 times and record the number of heads. Toss a biased coin 15 times and record the number of tails. Roll 3 dice 10 times and record the number of times a total of 5 occurs. Draw a card from an ordinary pack of 52 cards and record whether it is a spade or not. Repeat the experiment 15 times, replacing the card after each trial.
Okay, so here what is given. So these are the experiments. These are the examples, few examples of binomial. Look at here. Here in all the cases, number of trials is given. How many times we try? We try 10 times or 20 times. And then now success is specified clearly. Number of heads, number of trials. So head, number of, okay, what is the success? It is given clearly. And every time, okay, the probability of success is not changing. When we toss the coin first time or 10th time, probability of success will not change, isn't it? Probability of getting head will be always 1 by 2. Probability of getting tail will be always 1 by 2. So it is not changing. Okay, now look at the next experiment. Now read the next paragraph, Aparna. Aparna, can you read the next one? Aparna, is it okay, Aparna? Okay, otherwise Karthik, you read it. Karthik.
However, the following are not binomial experiments. Toss a fair coin until 3 heads are obtained. N is not fixed before the experiment.
Okay, Aparna.
Draw a card from an ordinary pack of 52 playing cards and record whether it is spade or not. Repeat the experiment 15 times without replacing the card after each trial. Trials are not independent. P changes from trial to trial. Draw a card from an ordinary pack of 52 playing cards and record whether it is a spade, heart, diamond, or club. Repeat the experiment 15 times, replacing the card after each trial. There are 4 possible outcomes.
Is it clear, children? Look at the case, the examples given here. These are some examples. Like this, some situation will be given and you will be asked why it is not binomial or is it binomial. So look at the first case. A fair coin is tossed until 3 heads are obtained. Till you get 3 heads, you are going on tossing. So how many times you try the experiment? We don't know. Number of trials is not given exactly. Is that no? So that is not a binomial. Look at the next case. Draw a card from an ordinary pack of 52 cards. We take a card, we look at whether it is a spade or not, and we replace it. Okay, we keep it separate. So when you keep it separate, what happens? Every time the probability is changing. First time when you take the spade, it will be 13 by 52, isn't it? Now you remove it. So what happens to the probability of getting the second spade? Tomlin? Initially, when we take the spade, the probability is 13 by 52. Now we have removed one spade. Now what is the probability of selecting the second spade?
Ma'am, 12.
Yes, 12 by, correct. 12 by
51.
51. Total number of cards also changes there. Is it clear? Is it okay? So it is not. Now look at the third case. Third case, it is given. We replace it. We take the card and replace it. But in that case also it is not binomial. Why? Why, Aditya? Why it is not binomial? Look at the third experiment. Read the experiment. Draw a card from an ordinary pack of 52 cards. Record whether it is spade, heart, diamond or club. Repeat it 15 times. Number of trials also specified. In that case, here it is given it is not binomial. Why? What is the reason?
You're replacing the parts.
We are replacing. Look at that. It is given. Replace the card after each trial. It is in there. Look, read the question. Third one. We are replacing the card after each trial. Then why it is not binomial? Yes, Karthik.
Possible outcomes is not 2.
The possible outcomes. Yes, correct, Karthik. Okay, look at there. We are not specifying which is the success. Okay, what is here? Look at there. The outcomes, we are taking it as spade, heart, diamond and club. 4 outcomes are there. And the success is not specified clearly. Is it clear? Okay, if it is given getting a red card is success, means we can take the getting a black card as failure. But here, the which is considered as success, which event is considered as success is not given. So we will, okay, the multiple outcomes are there, multiple possibilities are there. It may be a head, it may, sorry, not head. Here it may be a spade or it may be a diamond or club or whatever. Okay, so the outcome is not specified clearly. Okay. Now we are going to do few questions based on this. Write the question, children. Okay, this one is an easy one. Binomial experiment is an easy one. Okay. Now, if you are thorough with the formula, we can do the problems easily. So once again, recall the formula. What is the formula we have learned? Binomial distribution is given by? Binomial distribution is given by? Yes. Binomial distribution is given by Aishwarya.
NCR P raised to R Q raised to N minus R.
NCR P raised to N minus R Q raised to R, where N is the number of trials, R is the number of success, P is the probability of success, and Q is the probability of failure, where P plus Q is 1. P plus Q is always 1. If P is given, you can find Q. Okay, if Q is given, we can find P. Okay, similarly, don't think all, okay, suppose you have 20 bulbs. We have 20 bulbs. We are going to select a defective bulb or defective ball. So the question is, find the probability distribution of selecting a defective bulb. Okay, we have 20 bulbs. We are going to select one bulb. Okay, the probability of success is defined as getting a defective bulb. So don't think that always success means always selecting a good thing. It is not like that. Is it clear? What is asked, that is your success. Suppose you are asked to select a defective bulb means selection of defective bulb is the success. Selection of good bulb is failure. Is it clear? So what we have to find, that is our success. Is it clear? Find the probability of taking a red card, means selection of red card is success. Then selection of black card, we can take it as failure. Okay. Now look at the first one, exercise 9.3, first question. Tomlin, read the first question, Tomlin.
Ma'am, 9.4 now.
9.3.
Ma'am, a coin is tossed 5 times. Find the probability of getting at least 4 heads, at most 4 heads.
Okay. At least 4 heads. Second one, at most 4 heads. At least 4 heads, and next one is at most 4 heads. Okay, now listen, children. Sit straight. Sit straight. Listen, all of you. A coin is tossed 5 times. So, how many times we try this experiment? So, instead read the question, you write what is given. Okay, being MCQ and all, I have told you earlier, don't write more elaborately. Okay, you read the question and write it what is given. So, a coin is tossed 5 times. So, number of times we try is 5. Number of trials is 5. Find the probability of getting, look at the first case, at least 4 heads, at most 4 heads. So, what is our success? What is the success here? What we have to take as success? What is asked? Find the probability of getting at least 4 heads. So, P denotes getting a head. Probability of getting head. Why we consider that as P? Because in the question it is asked if we want to find the heads. So P is probability of getting the head as success. So when we toss a coin, probability of getting a head is 1/2. So it will be Q. Q is also 1/2. Okay, once this case is given, you write the probability distribution. What is the distribution? P of x is equal to R is NCR P raised to R Q raised to N minus R. Here N is given as 5. 5CR half raised to R half raised to 5 minus R. 5CR half raised to R half raised to 5 minus R. Now use the binomial. Okay, use the laws of exponent. A raised to M into A raised to N. What is A raised to M into A raised to N? A raised to M into A raised to N is A raised to M plus N. So it happened R plus 5 minus R. So these two will get cancelled. So we'll get 5CR half raised to 5. Okay, so this is the binomial distribution. X is equal to R. Now look at the first part asked. What is asked? You are asked to find at least 4 heads. What is the meaning of at least 4 heads? At least 4. It means at least 4.
Minimum 4.
Minimum 4. Maximum is?
Not specified.
Maximum here allowed is 5, isn't it? Because we do 5 trials. So listen, children. Listen. So at least 4 heads means x can take value 4. We can get 4 heads, or x takes the value 5. Only these are the 2 possibilities. X is equal to 4 or x is equal to 5. At least 4. At least 4 means 4 or more. Minimum 4 and maximum 5. Why here maximum 5? Because we do the experiment 5 times. So x is 4 or x is 5. Or means in probability we use plus. Or either x is equal to 4 or x is equal to 5. So or we put plus. Now you substitute x is 4. So in the place of r we can put 4. So 5C4 1/2 raised to 5 plus x is equal to 5. 5C5 1/2 raised to 5. Now we can take 1/2 raised to 5 as common. What is 5C4? What is 5C4? You have learned this last year. What is NC n minus 1? Yes, what is NC n minus 1? It is n. NC n minus 1 is n. And what is NCN? What is NCN? NCN is 1. What is NC1? NC1 is also n, isn't it? And what is the definition we have learned for NCR? N factorial by, okay, so write this, note down this in your formula booklet. Take the formula booklet and write down all these formula. Binomial distribution formula, mean, median, everything also you copy it in the formula booklet. Okay. Learn and write it. Learn and write. Okay, now listen. So what will be 5C4? It is 5. Plus 5C5 is 1. So 1 by 1 raised to 5 is 1. What is 2 raised to 5? 2 raised to 5 is? Shubham? 32 into 6. Simplify and write the answer. 6 by 32. Simplify and write the answer. So here it is the first case. At least 4 heads. At least 4 heads. Now let's do the second case. What about the second one? At most 4 heads. What is the meaning of at most 4? Anila Mohanan. At most 4. At most 4 means, Anila? What are the?
At the most, we should hit 4 heads.
At most means maximum 4 heads, isn't it? Maximum 4. So minimum possible value is? What is the minimum possible value?
1.
0. Here we take 0. Okay. While writing the distribution itself, we wrote 0. Okay, look at here. R takes value from 0, not from 1. Okay. R can take 0. Okay, note down that one. So, at most 4 heads means X may be taking 0, or X can take 1, or X may take 2, or X may take 3. Listen, don't write, children. Don't write. First listen. X is 4. So, how many times we have to calculate the probability? Don't write. First listen. At most 4 heads means maximum 4. So, it may be 0, 1, 2, 3, 4. So, how many times we are writing here? We have to calculate the probability 4 or 5 times, isn't it? Instead of this, what you can do, total how many trials we have? 0, 1, 2, 3, 4, up to 5, isn't it? So, we know that sum of all probabilities is 1. Sum of all probabilities is 1. So, here, instead of finding all these things again and again, easily we can write this as 1 minus. The question is P of X at most. Okay, at most means less than or equal to 4. That is same as we can take the negation. 1 minus P of X greater than 4. Okay, instead of writing all these steps, okay, we know this. Okay, if you write all those things and you calculate, it will be taking a length. Okay, you need 10 minutes or 15 minutes. Instead of that, what you can do? We apply the property of the probability distribution function. At most 4 means less than or equal to 4. We can write this as 1 minus P of X greater than 4. So it will be same as 1 minus greater than 4 means only one possibility is there. X is equal to 5. Is it okay? Is it clear, children? This way also you can do. This way also you can do. But this is a lengthy one. You have to do the calculations 4 or 5 times. But here if you do like this, the steps gets reduced. We can find it easily. X is equal to 5. When you put X is equal to 5 in binomial distribution, what you will get? What is the distribution? Distribution is 5CR 1 by 2 raised to 5. Okay. So here it will be 5C5 1 by 2 raised to 5. So 5C5 is 1. So 1 minus 1 by 32. So it will be 31 by 32. Is it okay? So whenever we are asked to find out the probability, we have to check. If you want to calculate more steps, we take the negation and we do. We subtract it from the total value and we write. Okay, we write the negation. X less than or equal to 4 will be same as from the total you subtract X greater than 4. And then we find out the answer. Is it okay? Is it clear, children? Shubham? Is it okay, Shubham? 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 Can you hear me, Shubham? Okay. Is it okay? Is it clear? Now write the next one. Write the next one. 10 coins are tossed. 10 coins are tossed. What is the probability of getting? 10 coins are tossed. What is the probability of getting? At least 8 heads. What is the probability of getting? At least 8 heads. 10 coins are tossed. What is the probability of getting? At least 8 heads. Okay, this is how many times we toss the coin. What is the number of trials? 10 coins are tossed. What is the probability of getting? At least 8 heads. What is the probability of getting? At least 8 heads. How to do this? So what is the value of n? Yes, tell me. Aparna, what is the value of n? Yes, Anila Mohanan, what is n? N is 10. Okay, we toss a coin and look at the outcome we need. We need head. So we can take P is same as probability of getting a head. What is the probability of getting a head? 1 by 2. So success is 1 by 2. So failure will be also 1 by 2. So that P plus Q is 1. Now what is asked? Probability of getting at least 8 heads. We are asked to find probability of getting at least 8 heads. Probability of getting at least 8 heads means it is same as X is great. Okay, at least means minimum, isn't it? So less than or equal to 8. Is it here? Less than or equal to or greater than or equal to? X is greater than or equal to or less than or equal to? At least. Okay. During the next period, we'll be discussing this. Find out what is the probability distribution. Find out the probability distribution. At least 8. Is it less than or greater than? Okay. Be ready with the answer. Okay, we'll be discussing that one also. Go through the case study questions, children. Okay. Thank you. Thank you.